So the rule for power of a product is A, B raised to the m power. What is being raised to the m power? A and B, right? Both of them. So A to the m power, B to the m power. Yes? So I'm going to fold this up. We can write ourselves some examples. Okay? A, B squared. A, B squared. What is that the same as? A squared, B squared. What about x squared y to the third, all raised to the fourth power? Dun, dun, dun. Wait, we have to use two exponent rules here? We have to know that both of these things are being raised to the fourth power is the first one. That's the one we're working on, right? But what else do we have to use? Power of powers, right? So what does this equal? X to the eighth, y to the perfect. X to the eighth, y to the 12th. Can I try to trick you? Okay. 2x y to the fifth raised to the third. What do you think? Okay, so I agree with x to the third, y to the 15th, but I tricked you on the first part. Because isn't it everything in there raised to the third power? So even the 2, what is 2 to the third power? So that's what people say a lot is 6, right? But is it 2 times 3 or is it 2 raised to the third power? 2 raised to the third power, which is 2 times 2 times 2. So 8. Absolutely. I did trick you twice, but now you have it figured out, right? And you're not going to let me trick you again, are you? Good job. Good. Okay. Any questions so far? So what about A, B to the 2/3 power? A to the 2/3, B to the 2/3, right? Okay. 16, A to the 5th, B raised to the 1/2 power. No, no, no. 16, A to the 5th, B raised to the 1/2 power. So you're trying so hard not to be tricked, and I appreciate that about you, okay? But I'm kind of, I guess, being mean in a way, not on purpose, okay? But the rule that you're trying to figure out right here, we haven't even talked to you about yet. But I had to go ahead and give you product of a pair, and I wanted you to have this example on your page. So can you trust me for a second that this is 4 and then A to the 5/2, which is what you said, and B to the 1/2? We'll come back to this in just a second. I just need you to trust me for a second that this is really 4. Okay? You know it's not going to be 8, though, don't you? Because it's not 16 times 1/2. It's 16 to the 1/2 power, right? Okay, ready for the next tab? Quotient of powers. What does that word mean? Quotient? Well, what does this word mean? Multiply, right? Product is multiply. That's why we have A times B, right? And then raised to a power, that's the power of a product, the power of a product. So do you see the difference between these two now? The product of powers, the product of powers versus the power of a product. Yes? So if this means multiply, what does quotient mean? Divide, right? So if I'm doing a quotient of powers, wouldn't that look kind of similar to product of powers? So quotient of powers is going to look like A to the m over A to the n. a to the m over a to the n. And if we are dividing like bases, what do I do with exponents? Very good. A to the m minus n. Got it? So x to the fifth over x to the third is what? X squared, right? Okay, because 5 minus 3 is 2. But what about x to the third over x to the fifth? What's that going to equal? See, some of you want to say -2, right? Because 3 minus 5 is -2. But we, God bless you, we cannot have negative exponents. Negative exponents, first of all, we haven't dealt with those before because they're not polynomials, right? But negative exponents are not all the way simplified, and we do not want that, okay? So here, I started in the numerator, and I said 5 minus 3, and where's my answer left? In the numerator, isn't it? What if I started in the denominator here? 5 minus 3? What if I left my answer in the denominator? Now, visual people, isn't this the same thing as this problem? X to the third over x to the fifth. Isn't that the same? What is x divided by x? 1. What's x divided by x? 1. What's x divided by x? What's left in the numerator? 1. And what's left in the denominator? 2 x's, right? So x squared. We simplified everything. This is a 1, this is a 1, this is a 1. There's a 1 left in the numerator. No, there's not always a 1. It's just that we simplified x divided by x, and that's a 1. X divided by x, and that's a 1. X divided by x, and that's a 1. See how 1 times 1 times 1 equals a 1? Does that make sense? And then there's x times x in the denominator. X times x is x squared. So you can think about it as if you start in the denominator, the answer stays in the denominator, or you can think about the fact that I'm literally simplifying x over x, and what I have left is x squared, and it's in the denominator. That makes sense? What about x to the 7/3 over x to the 2/3? X to the 7/3 over x to the 2/3. What does that simplify to? So 5/3, right? Why can I just straight up subtract those? They have a common denominator. When they have a common denominator, I subtract the numerators and keep the denominator, don't I? Everybody okay so far? Okay. After quotient of power is power of a quotient. So this looks like A over B raised to the m. Well, A over B raised to the m, what's being raised to the m? A and B. So I have A to the m over B to the m. Got it? So some examples. X over y to the third power. X over y to the third power, what is that the same as? X to the third, y to the third, exactly. Kind of. But typically distributing means multiply, right? And we're not multiplying 3 times x. We're multiplying the exponent 3 times the exponent 1. Does that make sense? Okay. A to the 6th over 2b squared. I'm trying to trick you here, just to give you a heads up. Don't be tricked. Okay. A to the what? Do you? Isn't that power of a power? And so what do you do for power of a power? Multiply. So a to the 24th I know, but it's not 4 times a is what I'm saying. It's 4 times the exponent. So that's the power of powers rule that we already talked about. If I'm raising a number to, an exponent to a power, I multiply those numbers. Okay? What about here? What about the denominator? Why did you say 16? That's where I was trying to trick you, by the way, because it's 2 to the 4th, right? It's not 2 times 4, because that would be 8, right? It's 2 to the 4th power, but then b to the 8, because that is multiplying. That's a power to a power rule, isn't it? So I chose to give you an example with a coefficient and an example, or an exponent, that were the same number, so you could see how this power acts differently on both of those two numbers. Does that make sense? 2 to the 4th power is 16, but b squared raised to the 4th power is b to the 8th. Do you see the difference? Two of you? Excellent. Okay. Next tab. Negative exponents. A to the negative n is 1 over a to the n. Now we could have talked about that right up here, right? We could have talked about that right up here, because if I have 3 minus 5, that's negative 2. But what is it saying for me to do with the negative 2? Move it to the denominator. And when I move it to the denominator, is it negative anymore? No. Okay. So some examples of negative exponents. First, let's do x to the negative 3rd. And what is x to the negative 3rd? 1 over x to the 3rd, right? But what if I have 1 over x to the negative 4th? What do I do with that? X to the 4th. Okay. Now, a silly story that I like to tell here is this. You're a kind and benevolent person, aren't you? Some of you, for the most part, right? This x right here, it is so unhappy. Can you see how unhappy it is? It's so unhappy that its exponent is negative. Okay? You, being the kind, benevolent person that you are, you want to help make this exponent happy. So it's in the numerator right now, isn't it? Where does it want to be? In the denominator. And when you move it to the denominator, what happens? It's happy. Okay? Where is this negative exponent? It's in the denominator, isn't it? You know it's so sad because it's negative exponent, right? When you move it to the numerator, what happens? So happy. It's so sad right here. Now it's so happy. Negative 2xy to the negative 3rd. Is the negative 2 unhappy? No, it's just grouchy. How do I know it's just grouchy? Its exponent is not negative, right? The exponent has to be negative for it to be unhappy. So that stays exactly where it was. What about the x? Is it unhappy? No, it stays exactly where it was. What is the only thing that's unhappy? The y. And when you move it to the denominator, which is where it wants to be, so happy. Is that silly? Is that mathematically sound discussions? No, but will it help you remember when to move negative exponents? I hope so. Okay. So what about x to the negative 1/2? What is that the same as? 1 over x to the 1/2. It's in the numerator and it's unhappy. You move it to the denominator and make it so happy. What about 1 over x to the negative 3/4 power? What do you know about this x? It's so sad, right? When you move it to the numerator, so happy. Yes? Okay, last tab. You ready? Other. Cool stuff. Now that's not the technical term. We're just writing that. Okay. Other cool stuff. First thing I want to tell you is when we have fractional exponents, we have a to the m over n power. I need you to know that the numerator of a fractional exponent is the power, and the denominator of the fractional exponent is a root. Okay? So a to the 1/2 power is also the same as the square root of a. Does everybody understand that? A to the 1/2 power, the 1 is the power, so it's just a to the first, which is just a, and the denominator is the root, so it's the square root of a. Does that make sense? Please go back to the tab that we called power of a product. I told you we would come back here, didn't I? We went from 16 to 4. How did we go from 16 to 4? 16 to the 1/2 power. What did we just figure out? Raising something to the 1/2 power is the same as the square root. What is the square root of 16? 4. Does everybody understand? That makes sense now? Okay. So what if I have a to the 2/3 power? What is that the same as? The top is the power, so a squared, and the bottom is the root. So I have a cube root of a squared. Yes? A cube root. Here, let me zoom in just a little bit so you can see it. Is that good? A cube root of a squared. God bless you. Anybody have any questions so far? Now, we need to write 2 more things on here, and then we need to draw some pictures. Okay? Specific pictures, not just any random pictures. Okay? I need you to know that x to the first power equals what? Anything to the first power is just itself, isn't it? And this one is almost as important, if not more important. What's anything to the 0 power? It's 1. Can I try to draw you some pictures and explain that? Okay. And yes, I do want you to draw this. Would you agree that that is 2 to the first power? So it's 2, right? Would you agree with that? So if I say 2 squared, what have I done with this? I've multiplied it by 2. I've doubled it, right? So I'm going to take my original picture, and then I'm going to double it. How many are there now? 4. You okay with that? What about 2 to the third? What have I done now? Well, I've doubled this one, haven't I? Multiplied this one by 2. So I've doubled it. So I'm going to start off with my original one, and then I'm going to double it. How many do I have now? 8. Now you knew that 2 to the third power was 8, right? But do you understand why now, even if you have a picture, does that make it a little bit clearer? Okay. What about 2 to the fourth? Because I doubled this one, right? So I'm going to take my original shape, and then I'm going to double it. And when I double it, how many do I have now? 16, right? Now, there's some patterns in this set of pictures right here. Does anyone see a pattern? There's like 6 or 8 patterns. What do you mean? Like the size of the shape? So this is doubling every time, right? The actual shape. What other patterns do you see? Somebody else. So the exponent started with 1, and then it went to, and then, so the exponent is increasing by 1 every time? What about the actual number? What's happening to it? It's multiplying by 2, right? What about the actual shape? What shape is this? A rectangle. What shape is this? And then a square, right? So you see a lot of different patterns here. I'm not saying that those are the only ones, but can we stop right there? Okay? Because where I need to go is backwards. I need to go to 2 to the 0. 4, 3, 2, 1, 0. That would be the next pattern, right? Square, rectangle, square, rectangle, square. Divide by 2. What should it be? It should be a square that is 1 square, right? Do you see why 2 to the 0 is 1? Like visually, do you see why it is? It follows all the patterns, doesn't it? What if I keep going? What about 2 to the negative 1? Square, rectangle, square, rectangle, square. Rectangle that is half as big as the previous one, right? So this is 1/2, isn't it? What about 2 to the negative 2? Square, rectangle, square, rectangle, square, rectangle, square that is half as big as the previous one. But if we think about our negative exponent rules, this 2 is unhappy and it's in the numerator. Where does it want to be? In the denominator.